This lesson, we will learn about how acids and bases are defined and how they're written. The first way of defining acids is given by a Swedish chemist. His last name is Arrhenius. His real name is Svante August Arrhenius. Okay, he said that an acid gives H plus and a base gives OH minus. HCl gives H plus and Cl minus, and NaOH gives Na plus and OH minus. You can see that drawing here. When NaOH solid dissolves, you get those two substances. When HCl, which is actually a gas, dissolves in water, it becomes H plus and Cl minus. Remember, every time you remove the H plus, that the electron that used to belong to it, it has one electron, now goes with the Cl. So now Cl has a -1 charge. The next definition is given by Braunstead and Lowry. These are two scientists, Braunstead, and the other scientist, Lowry, is sometimes forgotten and not included, so you just say Bronsted acid. In this definition, the acid gives the H plus and the base will take the H plus. Okay, for example, this gives H plus with the acetate ion, -1, +1. This base will take the H plus and become water. This ammonia can also take an H plus, and let me show you what it becomes. If you drew the Lewis structure for ammonia, it looks like this. When you add the H plus, it has no electrons. So over here where there are two lone pairs, it has room for the H plus. Okay, so when it goes there, it becomes NH. Now it has 4 H's, and the charge, this used to have a neutral charge, +1, and now it has a +1 charge because you're adding a proton to it. Okay, this one can also take an H plus, it's also a base, to make, now you have H2, 2 H's, and CO3. As you can see, this is a negative, and that's a plus. Together, they become neutral. So you might wonder, why are there two different definitions? The first one is too narrow. It only allows for one type of base, and that's hydroxide. After that, they found, oh my goodness, there are so many more bases out there. So Bronsted is a more generalized definition where it includes more bases. The way I remember it is A, Arrhenius starts with an A, and Bronsted starts with a B. This goes first in the alphabet. It is the most narrow definition, and then B is the more broad definition with more bases. So when you read your book, you will see that sometimes the H plus is written as H3O plus. I'm going to show you what these two things are. This is the same as this. This is called the hydronium ion. And this is just a simplified version of writing this. Simplified version. So the hydronium ion looks like this. It has, first you start with water in the beaker, if there's H pluses in there. So H plus is nothing but a proton, and you can see that picture here. Hydrogen with a 0 charge has its proton and electron. When the electron leaves and gets given to chloride, for example, it is nothing more than just a proton. So this proton is way too small. It is a bare proton with that size, and it's so small that it cannot exist alone in an aqueous solution because it is so attracted to water. Therefore, in water, these two will come together and become the hydronium ion, written as H3O+. So this is the hydronium ion. The reason they write it like this sometimes is because they're just being efficient. This is the same thing. Please pause the video as you write the Lewis structure for H3O+. Remember, first thing you do is draw the skeletal structure, 3 H's, put the valence electrons in the bucket. Go ahead and do that now. You should have counted the valence electrons as 9 because it has a +1 charge. That means 1 electron left, giving 8 electrons. So you have bonding pairs first, 2, 4, 6, and 8. So this whole thing cannot exist unless you give away an electron. This is H3O+ or H+. Okay, so sometimes the book will write this equation, HCl and water. Well, first, the way we were writing it looks like this. HCl becomes H+ and Cl-. Or the same thing as when the H goes into the water, it becomes H3O+ and Cl-. You can write it either way. These and this are the same. Okay. So, as you can see, this is water right here. Sometimes water can split apart as follows. The OH- comes off, and then the H+ goes the other way. So in this equation, water can be H+ and OH-, which means water can be both an acid and a base. A name we call that is amphoteric, a substance that can be both an acid and a base. Okay. Water is an acid. Acids means they give H. That means you're going to give the H to the base. So this is water is an acid, which means this must be the base. As you do that, the NH3 you will become NH4 with a plus because you're giving it an H+, the proton. As a result, you will have OH- left. Water as a base, bases will take H's. As a result, you will make H3O+ and C-. So this shows you monoprotic, diprotic versus triprotic acids. Monoprotic gives 1 H, diprotic gives 2, triprotic gives 3 H's. So you're going to write an equation. When you write the equation, remove 1 H first, and what's left over is HSO4-. So make sure that you put the -1. The reason it's there is because you're removing a proton from the H and you're leaving an electron behind. This substance can give another H, so HSO4- can give another one. It's diprotic. And then now you're left with just SO4, and the charge is now -2 because you took away 2 H+ from it and left 2 electrons. So now it's -2, and that's what you memorized. Pause this video as you write the 3 equations for the deprotonation of phosphoric acid. So the first one will give 1 H, and you will get H2PO4-1. Okay, and then now you're going to give away another H that has a -1. That's the same as minus, it's the same as -1. Give away another H. You're going to have HPO4-2, and then HPO4-2. Give away another H+ is now PO4-3. So you were able to give 3 H's, H+. If you look at these two substances, NH3 and NH4+, tell me what's different. You're right, they're different by an H+. You can see this one has an extra H, and it has a +1 charge. This one has an extra H, and it's a +1, and so on and so forth. Okay, this is also a different by 1 H, as you can see. If you add these together, it becomes this. These substances are called conjugate pairs. Okay, these two substances are called conjugate pairs. Conjugate pairs are different by 1 H+. If I were to label the conjugate pairs, this H2O and this H3O plus are different by 1 H, therefore they are pairs. This is the acid, and this is the base. Okay, they're conjugates of each other, so sometimes they say that's the base and this is the conjugate acid. Or sometimes they say this is the acid and this is the conjugate base. Okay, and then this is a conjugate pair with this substance. Please pause the video as you write the answers for these two equations. Here are the answers. Go ahead and pause the video as you correct your answers. For practice, classify as Bronsted acid or base. This is definitely an acid because it can give an H. Please pause the video as you answer the rest of the questions. Here are the answers. The confusing one here is the HCO3 minus. As you can see, it has room for one more H, so it can be a base, and it has that H that to give away, so it can be an acid as well.